Hello, hello! Today we begin one of the most fun lessons we'll do in this chapter. We're going to talk about simplifying cube root radicals in the denominator. So earlier when we did square root radicals in the denominator, all we had to do was multiply both the top and the bottom by whatever was in the radical. If we have cube root radicals, it's a little bit different. This is where it's going to become really important to remember that this is actually x to the 1/3 power. If you actually want to write it like that, I suggest that you do. It might actually be helpful. I'm going to do that for this lesson, and then you can leave it as a radical in the future if you would like to. So right here I'm going to go ahead and rewrite this as 4x to the 2x squared all to the 1/3 and x to the 1/3. From here, we see that because there's a radical in the denominator, we actually need to simplify this. But at the top, this part is already simplified. There's nothing more we can do. 2 doesn't have any perfect cube roots, and this can't be divided by 3 evenly. So it's already done for us. When we're looking at this, we still need to multiply it by something on the top and the bottom. However, we can't just multiply it by whatever's inside the radical. We're going to remember, if there's no exponent on the x, this is actually x to the 1. So when we multiply it, we're going to multiply it again by a cube root radical. So I'm just going to go ahead and put this here. So you can see what I'm doing is just like I did with the square root radicals, except this time it's a cube root radical. What goes on the inside is slightly different. We need to make sure that whatever is on the inside of this exponential expression here, when we add the exponent to 1, we need to make that number divisible by 3. So the closest divisible by 3 number to 1 is 3. So when we take that closest divisible by 3 number, and we subtract this exponent here, so 3 minus 1, we get 2. That tells us that what goes on the inside here, we take the same base, x, and we put x squared, x to the 2. Okay, we multiply both the top and the bottom, so technically it doesn't change, except now what's going to happen, we're going to get 4x times 2x squared, and then because these are both raised to the 1/3 power, these are both being cube rooted, we can combine what's on the inside. So originally we had x squared, now we're multiplying it again by x squared. We're going to just kind of write that out like that, just for now. And on the bottom, here's where things get a little bit different. Because these are both in cube root radicals, we can just combine the insides by adding the exponents, because they're being multiplied. So we add 1 plus 2, and we get x to the 3rd, all to the 1/3. Because we've done that, we're now able to simplify. Let's tackle the top first. On the outside, we have 4x, nothing has changed. Inside here, we now have 2x to the 4th, all to the 1/3. On the bottom, we have x to the 3rd to the 1/3. But if you multiply 3 times 1/3, you just get x to the 1. Now looking at this, you see that you have x to the 1 on the top and the bottom. So these actually can cancel out. We're going to go ahead and simplify that. Now we're almost done. The last thing we see is that now this number, this exponent on the inside, is greater than 3. So we need to simplify that even further because it can be broken apart just like we did yesterday. So we're going to have 4 times 2, which doesn't have any perfect cube roots, but I'm going to split this into 2x to the 3rd and 2x to the 1. So I just took 4 and I subtracted 3, and I got 3 and 1, all to the 1/3. When I use the product rule to break this apart, I can just kind of go in here and say, well, I'm raising x to the 3rd to the 1/3. When I do that, we just kind of go, oh, it's going to actually simplify. X to the 3 divided by 3 is 1, and we get 4x on the outside of the radical times 2x to the 1/3. The last thing I can do when I'm finished up is simply write it again, but as a radical. So 4x all to the cube root radical of 2x. And then it's fully simplified. Let's do another one, even grosser this time. Looking at this, I have the cube root of 64, x to the 7th, y squared, all over y to the 10th. When I look at this, the first thing I see is that, well, because all of this is inside the radical, I can simplify y squared over y to the 10th right away. Because it's a division, I subtract the exponents, or I can just say I can cancel out 2 of these y's, and I have 8 left over down here. What I'm going to end up with is the cube root of 64 x to the 7th over y to the 8th. If I look back at my quotient rule from a couple of lessons ago, I can split this into 2 parts. I can split it into the cube root of 64 x to the 7th all over the cube root of y to the 8th. As always, I'm going to take care of the top first. Using the product rule, what I can do is split this into multiple parts. With the number, I'm going to look for any perfect cube roots on the inside. Here, I'm going to split it into pieces that can be divided by 3 and pieces that cannot. I'm going to have the cube root of 64 times the cube root of x to the 6th times the cube root of x to the 1 all over, and we're going to do the same process here. The closest number that's divisible by 3 to 8 is 6, so I'm going to have the cube root of y to the 6th times the cube root of y squared. Just a kind of heads up here, these parts here are the parts that are going to stay the same and cannot be changed. Moving forward from here, I know that the cube root of 64 is 4, so that goes to the left on the outside of the radical. If I divide 6 by 3, I get 2, so I have x squared. And then this part here cannot be simplified, so I just have x on the top, cube root of x. On the bottom, again, I have 6 divided by 3. I have y squared times the cube root of y squared. I still have not fully simplified this expression because I have a radical in the denominator, which means I have to somehow get rid of this. Again, I have to remember that this bottom expression here, I need to find a number to multiply both the top and the bottom by, so that this can be divided by 3. This number has to become divisible by 3, or we cannot remove it from the radical. So this time I'm going to do it by leaving the radical signs the way they are. I'm not going to rewrite it as a fraction exponent, but it's the same concept. On the top and the bottom, I need to multiply by some number that will make this become 3, so 2 plus 1 is 3, or you could say 3 minus 2 is 1. So I'm going to multiply it by the cube root of y to the 1 this time. Because I'm multiplying it by the cube root of y to the 1, let's just take care of the top part first. I have 4x squared times the cube root of x times y on the inside, and on the bottom I have y squared times the cube root of y to the 2 plus 1, which is 3. Simplifying that even further, I then have 4x squared times the cube root of xy all over, and if I take the cube root of y cubed, that just becomes y to the 1. So I have y squared times y to the 1, or, again simplifying even further, I have y cubed on the bottom.